This problem asks us to predict under what temperatures reactions will be spontaneous without doing any calculations. The thermodynamic property that determines whether or not a reaction is spontaneous is free energy. So the reaction that we need to consider is the following. We have the free energy is equal to the enthalpy of the reaction minus the temperature times the entropy of the reaction. So let's look at the first example. So the sign on the enthalpy is easy. That's given to us as negative 906 kilojoules. In order to determine under what temperatures the reaction is spontaneous, I also need to know what sign the entropy has. So we want to know, is the reaction becoming more disordered or less disordered? In this reaction, I have all gases, but I have 9 moles of gas on the reactant side and 10 moles of gas on the product side. So over the course of the reaction, we're breaking the molecules up into more molecules, so it's getting more disordered. So in that case, the sign on the entropy we know is going to be greater than 0. So if I consider my equation, I have a negative delta H, that's minus a temperature times a positive delta S. If I want to know if the reaction is spontaneous at low temperatures, the easiest thing to do is consider the temperature to be 0. In that case, only the entropy term exists when the temperature is equal to 0. So when the temperature is equal to 0, or for low temperatures, delta G is negative, so the reaction is spontaneous at low temperatures. To consider high temperatures, I want to pick an arbitrarily high temperature. The easiest one to pick is infinity. So at infinite temperature, that means the only term that we have to consider is the entropy term, the minus T times delta S. Because in this case, delta S is positive, negative T times a positive number is going to be negative. So this reaction is also spontaneous at high temperatures. So it's spontaneous at low temperatures, it's spontaneous at high temperatures. So this reaction is spontaneous at all temperatures. Let's look at another example. This reaction is again exothermic. Delta H is less than 0. To determine the entropy, I consider that I'm going from 3 moles of gas to 2 moles of gas. So the system is becoming less disordered. In this case, the entropy is decreasing, so delta S is less than 0. So I'll consider the same thing again, the signs of my enthalpy and entropy. Delta H is negative. That's negative T times a negative delta S. So just as in the last problem, at low temperatures, I'll consider T is equal to 0. So this term I don't have to consider at low temperatures. At low temperatures, delta H is negative. Delta G will be negative. So the reaction is spontaneous at low temperatures. At high temperatures, if I consider T to be infinity, then I only consider the temperature and entropy term. In this case, I have a negative times a negative, so this entropy term is going to be positive, so at high temperatures the reaction is not spontaneous. So this reaction will be spontaneous at low temperatures, but not at high temperatures. All right, and let's do one more example. All right, for this reaction, we're not told what the delta H is, but we should be able to figure it out. So when I go from a liquid to a gas, I have to add energy to the system. So that means that I'm adding energy to the system, so that means that delta H is going to be endothermic, or delta H is going to be greater than 0. If I consider the entropy, I'm going from a liquid to a gas, so I'm going from less disorder to more disorder. So in this case, delta S is also positive. So now if I consider my reaction, I've got delta G, I've got a positive delta H, minus T times a positive delta S. At low temperatures, again, I'll set T is equal to 0, so I only consider the enthalpy term at low temperatures. In this case, because delta H is positive, delta G will be positive, so at low temperatures, the reaction is not spontaneous. For high temperatures, I consider my entropy term again. In this case, I have a negative times a positive, so the entropy term will be negative, so that means at high temperatures, the reaction will be spontaneous. So not spontaneous at low temperatures, this one is spontaneous at high temperatures.